Hello everyone. So today we would like to give you get more knowledge about introductions to computer system. This is my teammate. It is Jacqueline, Nurhamiza, and Yosyang Ching, and we are from DIT1F. Without wasting your time, I would like to give you some introductions about motherboard. So, what is motherboard? A motherboard is the main circuit board in a computer that connects all the different components and allows them to communicate with each other. It also acts as the backbone of the system, holding essential components like the CPU, central processing unit, memory, RAM, storage devices, graphic cards, and other peripherals through ports and slots. The motherboard also contains the BIOS, basic input or output system, which helps initialize and manage these components during startup.
For your information, motherboard have full types of functions. It has component integrations and connectivity, power distributions, data transfer and communications, and lastly is system boot.
Alright, so I will explain about functions of motherboards. As I mentioned just now, it's got 4 functions of motherboard. The first one is component integrations and connectivity. The motherboard connects and integrates all critical components of the power, such as CPU, RAM, storage devices, and peripheral to allowing them to communicate and work together. Second is power distributions. It distributes electrical power from the power supply to all connector components to ensure that they receive the appropriate power for their operations. Third, data transfer and communications. The motherboard facilitates data transfer between various components using buses and interfaces like PCIe, SATA, and USB. To ensure efficient communications between the CPU, memory, and storage devices. Last but not least is system boot. The motherboard houses the basic input-output system, firmware, which initialize hardware components and manage the boot process when the system is powered on. It ensures the proper configurations of the system to start the operating system.
Next, I would like to explain to you the differences of 4 type PSU in common use and describe the functions of the connectors to power supplies. For your information, power supply units are responsible for converting electricity from a wall outlet into usable power for computer internal components. So, the first one is ATX power supplies. Second is SFX power supply. Third is EPS power supply, and lastly is modular power supply.
For your information, power supply units are responsible for converting electricity from a wall outlet into usable power for computer internal components. Alright, so the first point is ATX power supply. The most widely used power supply type of desktops, ATX stands for Advanced Technology Extended and follows a standard size and pin configurations. It is functions to provide power to desktop computer with a range of wattage capacities. It also includes several connectors to power the motherboard, CPU, storage, and other peripherals. Second is SVX power supplies. SFX stands for small form factors. Supplies are smaller than ATX units and is designed for compact or mini ITX builds. It is two functions deliver the same function as an ATX PSU but in a more compact design, often with a lower wattage for small, less power-hungry system. Third, EPS power supply. EPS stands for entry-level power supplies. It is a units that are used primarily for servers and high-performance workstations, and it's also offer more power connectors than a ATX supply and often a higher wattage. It is the function designed to power demanding system like server or multi-CPU setup, with extra CPU, power connectors, and greater reliability. Last but not least, modular power supply. Modular power supplies allow users to connect only the cables they need, and it's to reducing cable clutter inside the case. It is two functions to improve airflow and organizations by providing flexibility in cable management. And it's also available in fully modular. That means all cables are detachable or semi-modular. It is meant by some cables are fixed, others are detachable forms. That's all from me for the differences of 4-type PSU in common use and the functions.
So I will explain about wattage rating and give some examples.
First of all, watts. The wattage rating indicates the rate at which electrical energy is consumed or generated. It's a measure of power. For example, a hairdryer might have a wattage rating of 1800 watts. This indicates that the hairdryer consumes 1800 watts of power when in use. Higher wattage generally results in faster drying times. Besides that, a refrigerator might have a voltage rating of 200 until 400 watts. This represents the power consumption of the refrigerator while operating. The actual power usage might vary based on factors such as size, model, and energy efficiency. Other than that, a typical incandescent light bulb might have a voltage rating of 60 watts. This means the bulb consumes 60 watts of electrical power when it is turned on. The next one, watts. Watts measure the electrical potential difference between 2 points in a circuit. It represents the pressure that pushes electric current through a conductor. Voltage is essential because it drives the flow of electrons, allowing electrical devices to function. Electrical system in a car operates at 12 volts. Powers the car's electronics like headlights, starter motor, and radio. Moreover, an industrial voltage might have a voltage rating of 480 watts, used in industrial settings and large machinery. Powers heavy-duty equipment like factory machinery, large motors, and power generators, which is the opposition to the flow of electrical current in a circuit. Resistance determines how easily current can flow through a material or component. Higher resistance means less current flows, while lower resistance allows more current to flow. In addition, the filament inside a standard incandescent light bulb might have a medium resistance of 240 ohms. The filament resists the current, causing it to heat up and emit light. This is how incandescent light bulbs work. Furthermore, a high resistance of 10,000 ohm resistor used in an electronic circuit. Resistors control the current in electronic devices such as radios, TVs, or computers by limiting the amount of current that flows through a particular part of the circuit.
First of all, I will open the case and install a power supply unit. Use a Phillips head screwdriver to ensure the computer is unplugged and you are grounded to avoid static. Remove the screws on the side panels. Slide the panel off and lay the case flat for easy access. It is to identify the PSU slot at the bottom or top rear for the case. Place the PSU into the slot with the power connector facing the rear. Ensure proper airflow for the PSU. Align the PSU with the case screw holes. Use the provided screws to surely fasten the PSU in place. And identify the necessary cables. It is 24-pin ATX and 8-pin CPU. Do not connect them yet. This will be done. Ensure the PSU fan has enough space for proper airflow to avoid overheating.
Now I will explain the step of installing heatsink and fan. First of all, apply a small pea-sized amount of thermal paste, also known as thermal compound, to the center of the CPU. This paste helps to fill in microscopic gaps between the CPU and the heatsink, improving thermal conductivity. Then, place the heatsink onto the CPU carefully, ensuring that it is aligned with the mounting bracket or hose. Press the heatsink down onto the CPU. After that, we need to tighten the heatsink by using clips or screws, depending on the type of heatsink. Frequently, use a screwdriver and screws to secure the heatsink to the motherboard.
Connect the motherboard power cable. 24-pin ATX cable is the main power connector for the motherboard. Insert it into the large socket on the motherboard. Then connect 4 of 8-pin CPU power cable to the CPU power socket on the motherboard. This provides power to the CPU. Insert and connect storage device. Connect one end of each SATA cable to the motherboard and another end to your SATA drive, SSD or HDD. After that, connect SATA power cable from the power supply to your SATA drive. Connect from panel cable. Attach power switch cable to the PWR-S3 header on the motherboard. Later, connect reset switch cable to the reset SW header if your case has a reset button. Connect USB and audio port. Attach USB cable to the motherboard USB header. The cables are usually labeled and should match the header pin layout. Thereafter, connect audio cable to the motherboard audio header, usually labeled HD audio. So, this is a precaution step while opening motherboard. And handling a motherboard requires care and attention to avoid damage and ensure safety. Here are some precaution steps to follow. First, power down and unplug. Turn off the computer. Ensure that the computer is completely powered down. Unplug all cable. Disconnect the power cable as well as any peripheral device like keyboard, mouse and printer. Second, discharge static electricity. Use an anti-static wrist strap. Wear an anti-static wrist strap to prevent static electricity from damaging sensitive components. Attach the strap to a ground surface. Ground yourself. If you don't have a wrist strap, frequently touch a metal part of the computer case or a ground metal object to discharge static electricity. Thirdly, prepare your workspace. Clean and dry area. Work in a clean, dry and clutter-free environment to avoid introduction dust or moisture. Use a non-conducive surface. Perform the work on a non-conductive surface such as a wooden table or an anti-static mat. Lastly, handle with care. Hold by the edge when handling the motherboard. Hold it by the edge to avoid touching the circuit board or component directly. They minimize the risk of static discharge or physical damage. Avoid excessive force. Apply gentle pressure when removing or installing components to avoid bending or breaking delicate parts. We will explain the effect if motherboard installed incorrectly. First, system failure. The computer may fail to boot or power on at all. You might encounter error message or no display on the screen. Second, component damage. Incorrect installation can cause short circuit or physical damage to the motherboard and other component such as bent pin or damaged circuit. Third, overheating. Poor alignment or improper mounting may obstruct airflow or cooling system, leading to overheating of the CPU or other parts. Fourth, connectivity issue. Loose or disconnect cable and component may result in problem with peripheral storage device or another hardware. 5. System instability. You might experience random crash, freeze or instability affecting overall performance and reliability. 6. Performance problem. The system may run slow or exhibit degrade performance due to improper installation. That's all from me. Thank you.
In summary, the motherboard is the central component of a computer, connecting all essential hardware elements like CPU, memory, and storage. It ensures smooth communication and power distribution across components, making it a key factor in the system's performance, stability, and upgradability.
That's all from us. Thanks for watching.